Today we start lecture 5 and this is on non-conventional energy sources. So far in last 4 lectures we have discussed various conventional sources of power, namely thermal, hydro and nuclear. What are non-conventional energy sources? There are many, as I said in the beginning in earlier lectures. Today we will start with MHD. What is MHD? MHD stands for Magneto Hydrodynamic Generator. Gas turbines and several other renewable energy sources, which we will go across them as and when time passes. Of course, being the students of Renewable Energy Center, you must be reading in detail about them in various other energy courses. However, we will have a brief review of all these sources with the point primarily with the intention of how to generate electric power using them. Let us come to the magneto hydrodynamic generation. Now, what we were doing in conventional thermal power? We were releasing the heat by fuel. Fuel can be natural gas, coal or oil. We were having thermocycle, that is a Rankine cycle or a Carnot cycle, and rotational mechanical energy, that is a prime mover connected to generator, and electric energy used to be generated. So, there were two conversions, chemical to mechanical and mechanical to electrical. Now, all of you are aware that eta is equal to eta 1 into eta 2. Naturally, this eta has to be lower of the 2. So, efficiency was inherently low. So, two stages of energy conversion in conventional thermal, therefore, there was a low efficiency. The highest efficiency which you can achieve in a thermal power plant in the world is around 40%. In India, it is not cross much beyond 30 for various reasons. Let us not go into them. The best managed government power plant is Vijayawada, and best managed private power plants are Tata's, that is Bombay, Tata Electric Company, and captive power plant it is Renu Sagar, that is the Hindalco in Mirzapur district, or now district might have been changed, that was old district. What is wrong with the rotating machines? All of you have done, being electrical engineering students, electric machine courses, maybe 1, maybe 2, depending on which college or which university you have been. All these rotating machines have associated losses. There is rotational losses, friction losses, there are hysteresis losses, there are iron losses and so on. Plus there are maintenance problems. Anything which is moving will need more maintenance. However, as I said in MHD, everything is static and there is only one conversion. Fuel, there is a combustion of fuel, hot gases are formed at very high temperature 2500 degrees centigrade, and these gases pass through a very strong magnet that generates electric power. If you go to our energy center, downstairs there is a MHD lab. There used to be a big magnet of 1.8 Tesla. Tesla is nothing but Weber per meter squared. That magnet somehow has become now out of order, so it has been thrown out. Otherwise, there used to be magnet about a couple of years back in MHD lab. Whatever I just now said is written here. Conducting gas, MHD generator is a strong magnetic field and it generates electric power. here is a schematic diagram explaining the principle of MHD. There are books on MHD, you do not have to read them, this much is enough. Gas flow, as I said. Now, fuel can be again anything, can be coal, can be oil, can be anything. At 2500 at a high temperature, all right. So, that ionization takes place, and this is passed in a strong magnetic field plus minus anode cathode. There is a load, directly supplies power to the load, and there is a flow out. Now, this flow also has enough hot gases, why not use it? So, this can again be further used, maybe as a cogeneration form, maybe as a combined gas cycle plant. So, do not lose it to the atmosphere, this is further used, and that will improve the efficiency of the whole plant, because you are not wasting anything. As long as you do not waste, it improves, it is even economizes. For example, if you have some chapatis or some, I do not know what you do in hostel, in houses they are again used as some dish, and we do not throw those things away. Well, efficiency is around 50%, whereas I just now talked about efficiency of thermal power station, which has not crossed 40% anywhere in the world, even with so called modern technology, superheated steam, reheat turbine. I already explained you what is reheat turbine. You bring out the steam, pass it through a reheater, again bring it back. Of course, any such thing will have an additional cost. Cost has to be there. Well, so far the status of MHD research in the world, technological feasibility has long been established. There is no iota of doubt that it works. Economic feasibility has not yet been established. That is why you hardly see an MHD power plant anywhere. Why we were interested in MHD earlier on? Because we had a very good relationship with former Soviet Union, USSR, and they had lot of interest in it. They helped us, they supplied us technology. They had a 25 megawatt plant with a natural gas as a fuel in Soviet Union, former Soviet Union, Russia now. They were about to scale it up to 500 megawatt in early 90s, and there was a collapse of the empire. So, they could not do it, because they were doing something we also did in India. Trichannapalli or Trichy as it is called, BHEL has established a 5 megawatt MHD power plant. I have seen it with my own eyes working, but now it is not working because it has collapsed there. So, we have lost interest, and it is more or less like museum. If you visit Trichy now, they will show you here was our MHD power plant, that is it. So, it has stopped working because there is no interest. There are other countries also where MHD research is going on, like New Zealand, Japan, but not any significant power is generated anywhere in the world. Only research papers, PhDs, design of a burner, and so on. Now, we come to the next non-conventional energy source, and that is gas turbines. What do we do in gas turbines? Compressed air fed to the combustion chamber. There is a combustion chamber. Continuous combustion of fuel oil is maintained. Hot gases so produced run gas turbine, something like wind. There is some source which runs the turbine. If turbine is running, let us say prime mover, generator will run and power will be produced, as simple as that. Well, the efficiency of gas turbine is definitely lower than even thermal power plant. If it is 40, this is 30. Then you may ask me question, why you have it then? If its efficiency is even lower than the thermal power plant, which is assumed to be a low efficiency power plant, why do you want to have such a power plant at all? I will give you the answer within a minute. As I said, although less economical than thermal power plant, it is still used as a prime mover, PM is prime mover, for its ability to start and take load quickly. We have just done in one of the earlier lectures hydropower plant, and we hailed it as quick starting power plant, 5 minutes. But can you bring a hydropower plant to your rescue for short duration peak load? You can't go on establishing hydropower plant everywhere just to supply peak load. So, gas turbine, which is very handy, the land per megawatt required is very small, and it is not that costly, and gestation period is not that high, 8 years or 10 years, and that is why gas turbines, though low efficiency, is preferable wherever you have to meet the peak load for short duration. Peak load means short duration. If it is for long duration, it becomes an normal load. How do you call it a peak load, right? It is very much capable of meeting sudden peaks of system load. It is very quick starting. Can also be used as a synchronous compensator. What is synchronous compensator? Have you heard of synchronous compensator? You must have read it in your synchronous machine or in power system course in your 4th year. This is also called dynamic compensator. There are 2 types of compensation. Compensation of what? It is not power factor, it is 3 in 1. It is voltage, it is a power factor, it improves efficiency also. So, what do? You put a bank of capacitors, bank of inductors across the load. You do not need both simultaneously. Either you need capacitors or you need inductors. Why? Because either the voltage goes down or it goes up, it cannot do both simultaneously. Either you are inside the studio or you are outside, only God can be omnipresent. So, luckily we do not have the low voltage or high voltage problem simultaneously in the same system at the same point. Normally in India, as you all know, we have a low voltage problem because of the load being more than the generation. So, there is a voltage sag. Only in Ferranti effect, you must have learned in your undergraduate, we have the voltage at receiving end more than the voltage at sending end, and then we need this bank of inductors to supply negative watts. Otherwise, normally we have to supply positive watts, and that is you have to have a bank of capacitors, but this is a static compensation. How about dynamic compensation? That is a synchronous motor running at no load is called dynamic compensator. So, that sort of effect can also be used using this gas turbine. Fuel economy increases by using hot exhaust gases of GT in a conventional steam generation cycle. The item which I said in MHD also. Anywhere wherever heat is available, use it. That comes under waste power generation also. Don't have any waste at all. Let waste be your primary resource now, and let the new material be a secondary resource. That is the era in which we are living. Well, Delhi, we have 6 such units, gas turbines of 30 megawatt. I again wish to request you to go make a visit, use your energy forum or use whatever forum you want, or take 502, go yourself if nobody is funding your visit, and see in Rajghat you have this gas turbine station. So, you must go and see it. Arrange a trip, I am sure head will give you support. But you should do such things. I have told you so many things to go and see, like Badarpur Thermal Power Station, Load Dispatch Center in Katwala Sarai and so on. I do not know whether you are going to do any one of those things. Now, we come to the third non-conventional energy source of today's talk, geothermal power plants. What is geothermal? All of us know there is a heat inside the earth. All right. If you want to have a taste of it, go to Sona. You can arrange a picnic there near after Gurgaon, some 60-70 kilometers, and there is a hot water springs coming from the earth. People say all skin diseases can be cured if you go and have a bath there or whatever, you apply it. If you put a rice there in that water, it gets cooked in no time. So, there is a tremendous amount of energy available in the earth. Heat deep inside the earth acts as a source of power. Why waste it, since you have it? Steam coming from underground in Japan, US, Mexico, New Zealand, Australia, even India and Philippines is being used to generate power. How? What we do, this is your earth, this is how we show earth. Have two pipes, long pipes, send with in one pipe a water inside the earth. Here it will get converted into steam, send it back to the earth and use the steam directly into the turbine and then generator. So, power is produced. It is only initial expenses when you put these two long pipes, depending on what is your capacity of power station, how deep you should go. As you say, higher you go, cooler you feel, you must have heard this. Similarly, lower you go, hotter you feel. In India also, we are very smart people, we are very intelligent people, second to none as far as intelligence. Only thing is, the brain only works when it leaves India. It is either in US or Australia or UK. Here it does not work so much. So, we also have one megawatt geothermal power station in Ladakh, place called Puggy Valley. Another such station is there in Chomantang, again Kashmir. The installed capacity throughout the world is just 500 megawatt. But let me tell you, ladies and gentlemen, each megawatt counts, like each rupee counts. If you respect rupee, 100 rupee will automatically will respect you, because sigma is important. Do not think it is 1 rupee, save it, and that 1 every day if you save becomes 30, in whole year it becomes 365. 1 rupee can be made 10 rupees, 1 rupee has lost its meaning, maybe 10 rupees. I am talking about my student days, where 1 rupee had a lot of meaning. Especially in the volcanic region, which is enough in the world, you have seen Italy and several other places. Equator is definitely there, it passes through our Sri Lanka. There the heat is really good. Let me tell you, geothermal contributes to New Zealand. I was in New Zealand last year teaching there in University of Christchurch. This is tiny small country with just 4 million people, less than even you can say Pune or Nagpur population, and there 8% of power generation comes from geothermal, and it is very economic. Now we come to renewable energy sources. So far we have been talking about non-conventional. Renewable means there is no fuel is free and it gets generated automatically. Why it is important? Why should we talk of renewable energy sources? It protects environment. Environment has become a very big issue now in the world. There is a Rio conference, there is a Japan, Kyoto, and so on. Everybody talks about it. In practice, they hardly do precious little to protect the environment. In fact, there is a competition going on who spoils most. Sustainable development is a word which all of us pronounce every day 20 times. It has become a need of the hour. Any development has got to be sustainable. Not only you have to do well in minor 1, you have to do well in minor 2, then you have to do well in major or in between, whatever exercises are given or quizzes, announced, unannounced, take home test, seminars. In our energy maybe they are not doing, but in many departments they have several components to keep you on your toes and do better in life. They have enough academic pressure. So there has to be sustainable development. You just can't say in 2003, 2004 I will work and I take rest in 2004, 2005. No. The energy in energy area, sustainable development is only possible using renewable energy. Why? Because everything is limited. The coal is for 200 years. As I said, we do say that it is continuing for 200 years because we find more and more places, exploration where coal is there. Yet as I told you, availability versus affordability. As I said, Mercedes car may be available, but we can't afford it. So even if coal is available, can we afford to burn it indiscriminately? Why not leave it for our children and children's children, as is our Indian ethos? We do everything for our family, for our children. So leave coal also for our children. They will also need electric power. It is clean. The renewable energy source is clean. It is not dirty. Easy to use. Economically maximum viable with increased use. As the use will go on increasing, it will become more and more viable, because this is what the question is asked when you talk of renewable energy. What about cost? Anybody will get up and say it's no good, it's costly. Let me tell you, the conventional electric power, the cost is rising, and non-conventional energy power cost is coming down. This was 1 rupee per unit, has become 4 or 5 rupees, that used to be 10 rupees, it is coming down with more and more use and more R&D, better and better technology. Like for example PV, better materials are now being used, and then development in power electronics, development in computers have made it very cheap. Let us first talk about wind power stations. I think after solar, or maybe when sun started, wind also started. I mean, you can't say which came earlier. It is one of the oldest source of energy. If you go and see movies, olden days, 18th century, 17th century, Sindbaba, Aladdin, etc., etc., they used to go from one place to another in ship. Even Mahatma Gandhi went to England to attend that round table conference of 1931 along with G.D. Birla and its delegation in a ship. Ship works on the principle of wind energy, even if it is powered, because they chalk out their route in such a way that wind helps them. Winds, of course, are generated by solar heating of the atmosphere. Sun is the mother or father of all energy sources. If sun is not there, you won't get coal. If sun is not there, you won't get water, the hydropower. You won't get rains. 1940 was the year when they started attempting generating electric energy using wind. Why? What was the need? In fact, there was no need as such. In fact, until 1970, nobody talked of energy conservation, nobody talked of energy management. Thanks to those three steep hike in oil prices in 70s, that has changed the whole scenario in the world. Even US, the supreme power, of course those days there was another supreme power, USSR, they got threatened. One day their oil will be finished, and that is why this whole Middle East politics is there. It is just for oil, nothing else. Otherwise, who will care for any Middle East country? They have petrodollars. Merits are, it is plentiful, inexhaustible. It will never finish. Non-polluting, there is no carbon, there is no CO, CO2, SO2, NOx, nothing. No heat burden on atmosphere. It is not releasing any heat like your thermal power plant, nuclear power plant or anything. There is no greenhouse effect. What is greenhouse effect? The temperature of the earth is increasing every year. That is why this summer France, the temperature has touched for the first time 100 degree Fahrenheit. I mean, though they talk of SI units and MKS units, still in US the temperatures are shown in Fahrenheits and the length is measured in miles. They are not changing to kilometers or centigrade or something like that. It's still there. If you see their news, you will find the temperatures shown in Fahrenheits. High 80s, high, don't think they are centigrades. High 80 degrees centigrade means there will be nobody left. They are all Fahrenheits. So 100 degree Fahrenheit, that is about 37 or 38 degrees centigrade, which is nothing for us. In India we have 48, 47. So even in 38 degree there were so many people got killed because their sun is real very, very harsh. That is why you need all sorts of cream to avoid sunburns or even cancer, skin cancer. So the sea level is also rising, and who knows, one day there already we have lost quite a few villages in Andhra, coastal Andhra, submerged in the sea. And if this continues, maybe when you become of my age, there may not be Sri Lanka, there may not be Mauritius, there may not be, all under sea. They will say there used to be Sri Lanka here. Thanks to this greenhouse effect. And it is a real threat. All small island nations may not be there. If you indiscriminately go on burning coal, go on producing power, There, as I have been repeatedly telling you, there cannot be only plus points in anything. There has to be negative points. God has never made anything perfect. Even when He came on the earth, supposedly Ram and Krishna, there were also faults with them. One fellow left his wife, another fellow did so many things and killed Kauravas, etc., etc. What are demerits in wind power stations? It is non-steady. It is there and it is not there. If you go for a morning walk, oh, there is no wind today, there is no point in taking morning walk. Those of you who belong to villages, they know the people used to sleep outside. For what? Because the wind is blowing, the pure air of villages. If you sleep in Delhi, you may not find anything in the house in the morning when you get up. So, whether wind or no wind, nobody wants to sleep outside, and you check your doors 10 times before sleeping. Is it locked from inside or not? It is not only non-steady, it is undependable. You can't depend at 4 p.m. I will generate 10 megawatt from wind, and suppose wind is not there. So, you can't just, you had to have a standby arrangement. If you don't get an auto, you know you will take 620 or 650 from hostel gate. You had to have an alternative, and so you have to get out of your hostel room well in advance to catch a train when you go to your hometowns. Whenever wind is more than 30 km per hour, then only it generates power. That's, there is a minimum speed of wind which is required if you want to generate a power. If it is lower than that, so there is a critical speed, like your excitation, some resistance, critical resistance is required. You must have read in your machines course. Then these sites are isolated, they are not everywhere. Backup for continuity, you had to have backup, this is the real problem. Like CNG bus, you had to have a diesel backup, that is a multi-fuel operation is required. Now the I think Birlas have brought an ambassador which can run through both petrol and diesel. So, if you have petrol, you use petrol, if you have diesel, use diesel, and slowly it will be 4 fuels: CNG, that is gas cylinder, and then your diesel, petrol and battery, 5, and whichever is economical depending on your are you within city, then battery is okay, something like Riva car which was shown in IT campus also. You were not there last year. That is a Bangalore firm is producing, and at one stretch you can go up to 65 kilometers. Again you have to recharge your batteries. There are 3 types of operation in wind power. What are they? Small, 0.5 to 10 kilowatt, something like mini, micro and small hydro, for isolated single premises. So, you are living in a village, in your field, irrigation, agriculture, and night you want to sleep there itself, a small house, small cottage, isolated, there is nobody in your field is very big, several acres. So, this much power is enough. Medium, for communities, I gave you an example of the 25 houses in Uttaranchal village which combined and started generating power, mini hydro power station. So, similarly they could have opted for wind also, but as I said, wind there is a problem, at least mini, there was water is guaranteed there, unless until it is too cold and it is frozen. So, only in that 1 month or 2 months, because more than 2 months I do not think we have that severe winter where water gets. Dal Lake got frozen once in 30 years or 40, where you can run a car on Dal Lake in Kashmir, but that happens very rarely. Large 2 megawatt to 5 megawatt. Please remember 2 megawatt to 5 megawatt is large in renewable, which is very very small for a conventional power station, but it is large in wind. We haven't yet gone beyond 5 megawatt in wind power station. 10 megawatt is coming, of course. For connection to the grid, then it is no longer works as an isolated wind power station or as an autonomous wind power station. It works as a grid connected. Any renewable energy can work in two modes, in a standby mode, or standalone mode, or a autonomous mode, or in a grid connected. Suppose there is a lot of wind here, but you do not need power here. Okay, I will still generate and feed it to the grid. Grid is always requiring power, so we can earn money. There are two types of wind turbines: horizontal axis and vertical axis. Horizontal axis is very popular. You will find most of the turbines used in the world are horizontal axis, but vertical axis has got certain advantages. So, the IIT Delhi, in our Center for Energy Studies, we have tried a DST project of 12 lakhs building a vertical axis wind turbine, and you can see it there in behind our center, behind block 6. There is a big structure of vertical axis wind turbine, wind power station, and you may request Professor Bhatti to show you how it works, how it generates power, and how bulbs are lit. It is right there. Here you do not have to go anywhere, unlike gas turbines, Rajghat, thermal power station, Badarpur, etc. So, just go and have a look at it. Another important statistics in wind is, it is a Denmark which first started generating power using wind, followed by US. There are in US lot of wind farms are there. Germany, Spain, and we are 5th in the world. Our total installed capacity is 1200 megawatt. Theoretical power. The power generation is given by this equation. P is equal to 0.5 rho A V cube. Of course, this is in watts. It is given here. 0.5 is 0.5. I do not have to explain what is 0.5, half. Rho is air density, density of air. It is 1201 grams per meter cube. V, of course, it will vary if with altitude. See, air gets thinner and thinner, and oxygen becomes less and less. That is why when you go to any hilltop, you carry oxygen with you, especially Mount Everest or something like that. V is not volume here, but a mean air velocity in, because English language has only 26 symbols. So, we have to use same symbol again and again for various purposes. V is voltage, V is volume, V is velocity, and so on. For a rotor of 17 meter dia and a velocity of 48 kilometer per hour, The theoretic, imagine how big the rotor is, 17-meter dia. That is why this our wind structure is very huge. If you go, I do not know whether you have seen it, and 265 kilowatt power is generated theoretical, but practically is just half, because efficiency is 50%. Most of the wind power sites are remote. They won't be in the midst of Bombay Nariman Point wind power station. There will be law and order problem if you have a wind power station, or in India Gate. So, they have got to be remote, a rural environment, island, marine areas. And that is why most of the wind potential in India is on coastal, Tamil Nadu, Gujarat. Tamil Nadu is 60%. It is a huge success story, and Gujarat is again 20%. If you visit Tamil Nadu or Gujarat, do see these wind farms, huge wind farms. Orissa, Maharashtra state, Rajasthan, they are all coming up now, because whole country is divided into 15 agroclimatic zones, okay, and those states, those areas which are coming in semi arid zone. There is an institution on arid in Jodhpur, that is the the desert. Arid means it is less water, but more wind. Rajasthan, there is no wind problem. That is why everything is done in the night time, because it's cool and it's windy, it's quite comfortable most part of the year. Installed capacity, as the potential in India is 45,000 megawatt, tremendous potential, if you can exploit it, if you can tap it. How much we have been able to do so far? Just 1267 megawatt as on 2001. You made another 100 megawatt for 2 years, that is all. It may be 1367 now in 2003, but I have no authentic data, that is why I am giving you 2001 as given by MNES, Ministry of Non-Conventional Energy Sources, because whenever you quote such data, you should be thorough and it should be correct. World potential, not potential, installed capacity today is 14,000 megawatt, which is roughly 100 times India's, and bulk of this 14,000 in Europe. Naturally, when I said 3 countries are ahead of India, barring US, all of them are in Europe, Spain, Denmark and Germany. Now, next time of course, we will talk of solar energy. Before we close, let me tell you the new trend which is coming in renewable energy sources, and that trend is rooftop. Earlier on, when there was no this 4th floor, now the 4th floor has come. Before you came, there was only 3 floors in those teaching blocks where energy is housed. You can very well see that 4th floor is not same as the remaining 3 floors. The construction is light, because the foundation was not meant to have another floor. So, roof, we will always have a roof available, and nowadays for security reasons nobody goes and sleep on the roof, same thing outside or roof, same thing. But you can have the power generation on the roof, small wind power stations. The research going on in IIT Delhi in energy center is how to generate wind power with small wind speeds. How small? Just 5 to 6 meters per second, because small wind is there available all the time. So, what we have done? We have developed a nozzle which amplifies the wind speed. There is a wind tunnel here also, incidentally. Lot of wind work is going on in applied mechanics department. Which is what is this? Is the aerodynamic principle, fluid dynamics. So, if you happen to visit to applied mechanics department, you see the wind tunnel and see how you feel about it. So, this wind, small wind speed gets amplified to big one, and that wind will have lot of power, and when it passes through a wind turbine and then attached to generator, it generates power. So, rooftop power stations are becoming very popular. You may ask me a question, what you do with that power? We use that power to supply the requirements of that building, and if you have still extra power, you feed it to grid, you sell it and start earning money. Or you can do banking and wheeling. What is banking and what is wheeling? I give you power here, you give me in Gwalior, my factory is in Gwalior, but I generate power in Delhi. I do not need power in Delhi, but you may be having factory here needing power. So, I sell you power here, you may have a power station in Gwalior, so you give me there. So, wheeling of power, banking of power. Okay, I give you today, tomorrow if I do not have you, then you give me, that is banking. What we do in a bank? We put money today when we have and we withdraw when we need. So, that is banking and wheeling of power, which has been made possible by renewable energy sources. And I think now roughly 5 minutes are there. So, I will ask you if you have any questions on whatever we have done till today, including today's lecture. So, any questions you have?
So, I am just unable to understand the power generating arrangement of MHD. Means what is the logic?
Well, logic is you have to read, of course, as you said, you must read the book, and we have not done it in detail. The only logic is when any ionized gas passes, not ionized, when any what you call fuel is burnt and the hot gases are formed at a very high temperature, and when it passes in a magnetic field, it gets ionized. So, the
magnetic energy is stored.
Not so, magnet is there. It is a big magnet.
Magnetic energy is stored in the magnet. No.
Yes, energy is naturally they cure with a magnet. There is a magnet therapy also. So, that power, when it plus anode is there and cathode is there, and the power can be, it is like a battery now, and the load, as I showed that figure, and it goes to the load. So, there are books on MHD, only MHD in our library. I do not want you to read the whole book, read just introductory chapter in case you want to know more about MHD.
Same as with wind energy, means how the kinetic energy is converted to electrical energy.
That is what I am saying. There is a lot of aerodynamic principles involved. In fact, there is a full course going on wind and hydro taught by Dr. Bhatti, and which I have finished in just about 15 minutes. So, naturally, if you are more interested in wind energy, again you have to consult your colleagues who are right now undergoing that course. I hope you know about it. Dr. Bhatti is teaching a course titled Wind and Hydropower. Am I right?
Yes, yes,
So, please, there must be your friends. Ask them same question, and but that much enough is given in the book also. How, but then if you want details, naturally you have to go, and there is another book also, Weedle, or what is that? 1986. It's given in my book in the end of the references. You can read that book as well. Or alternatively, you ask your colleagues who are undergoing this course, and they were whole semester, half the semester, they will be only talking about wind.
These are not so much details, but is it
Small detail, then you read my another book, Basic Electric Energy. There are numericals also solved there, and that book is there in our central library, Basic Electrical Engineering, and there wind is given in considerable detail, not as small as in power book. You know, you have seen our Basic Electrical Engineering book?
brown?
Not Brown, that is a power system engineering. Basic means Thareja equivalent. Something like Smith, something like Fitzgerald, Gabriel and Higginbotham. Not Fitzgerald, Kingsley and Humans. Huh?
Thin book, sir.
Not so thin. It used to be thin, now it is a big one. So there I have devoted 6 pages on wind energy. Unlike power book where it's only 1 page or 1.5 pages. I am happy that you are more interested in knowing. So that's because of the time. We have 4 segments to cover: generation, transmission, and distribution. It's not alone on generation. Forget about alone wind, which as Dr. Bhatt is doing. So, is it all right? Or you can come to me anytime. My upstairs office here, 2nd floor. So I will show you. Any other question? Or whatever you have done, whatever you have not done, I don't think I can reply in a couple of minutes. Because there are so many things which we can do. We can have a whole course on, I mean, indeed we have half course at least. Yes, anybody else? Okay then, so we stop here.